Hey, this is Professor Perez from Saddleback College. Today, we're going to look at substitutions for rational functions of sine and cosine. And of course, we cannot have a class without our student of the semester, Charlie. He better be ready to go. Charlie, what do you think this is? Yeah, wake up, get out a piece of paper and a pencil, and let's get ready to go. Today we're going to do substitutions for rational functions of sine and cosine. All right, okay. Well, here we go with our first problem right there. We're going to integrate 1 over 4 sine x subtract 3 cosine x dx. That's right. Now we're going to go through an ingenious substitution method developed by Karl Weistrass. Okay? And we're going to go through the procedure and outline what he did, and then we're going to actually apply it to this problem. So here we go, Charlie. First of all, let's do a little bit of trig right now. Sine of 2x is equal to what, Charlie? 2 sine x cosine x. 2 sine x cosine x. So what we're going to do is we want to develop a substitution for that sine x up there in the denominator of our fraction. Well, using this double angle formula, remember, why is it a double angle formula, Charlie? Because 2x is twice as big as x. That's right, because 2x is twice as big as the x. There we go. And so, using that fact, sine x should equal 2 times what, Charlie? Sine of x over 2. Very nice. Sine of x over 2. Similarly, cosine of x will change to cosine of x over 2. So, we're using the double angle formula, but our form is sine x equals 2 sine of x over 2 cosine of x over 2. Okay? Now, let's use the double angle for cosine. Cosine of 2x, we'll use this form, cosine squared subtract sine squared x, right? Okay, Charlie, now, if we do the same thing that we did here with the sine, cosine x is equal to what, Charlie? Cosine of x over 2. That's right, cosine squared of x over 2 subtract sine squared of x over 2. Okay, so there we go. Now, what we're going to do is we're going to develop a reference triangle based on this reference angle x over 2, okay? And so, well, how are we going to do that? Well, here we go. Here's our reference triangle, right? And here's the actual substitution that Karl Weistrass used. He said, okay, let's let u equal tangent of x over 2, Charlie. Okay, and we're going to put a restriction on x over 2. We're going to restrict x over 2 to quadrants 4 and 1 of the unit circle, negative pi over 2 to pi over 2. Okay, and tangent is what sides of this triangle, Charlie? Opposite over adjacent. Opposite over adjacent. So we have tangent of x over 2 is equal to u. That means u is opposite x over 2 and 1 is adjacent to x over 2. There we go. And what's the hypotenuse, Charlie? Square root of 1 plus u squared. Square root of 1 plus u squared. Very nice. We're reviewing our trig. Okay, Charlie. So now, let's go back. Remember the double angle. Sine of 2x was 2 sine x cosine x. Therefore, sine x was 2 sine of x over 2 cosine of x over 2. Right? And therefore, Charlie, look at our reference triangle now. We're going to replace sine of x over 2 with what? Look at your reference triangle. Here comes our substitution. Sine of x over 2 is what, Charlie? U over square root of 1 plus u squared. U over square root of 1 plus u squared. Very nice, because remember, sine is opposite over hypotenuse. Very nice, Charlie. Now, how about the cosine of x over 2? 1 over square root of 1 plus u squared. 1 over square root of 1 plus u squared. That's right, because cosine is adjacent over hypotenuse, right? For all you SOHCAHTOA fans. Anyway, okay, Charlie, so now, go ahead and multiply. What do we get on top? 2u. 2u, and on the bottom, 1 plus u 1 plus u squared. So there we go. Now we can replace sine x with this 2u over 1 plus u squared. Very nice, Charlie. So now, let's go for the cosine. Here we go. Remember, we use this form. Cosine of 2x is cosine squared subtract sine squared x, right? And therefore, cosine x was equal to cosine squared of x over 2 subtract sine squared of x over 2. Don't forget. Now, here we go. Cosine x, Charlie. Okay, we have cosine squared of x over 2. So we're going to square cosine of x over 2. And what was cosine of x over 2, Charlie? 1 over square root of 1 plus u squared. 1 over square root of 1 plus u squared. And similarly, we're going to square the sine of x over 2 to give us what, Charlie? U over square root of 1 plus u squared. U over square root of 1 plus u squared, that's what it is. And now we're going to go ahead and square this. So if we square the first one, what do we get, Charlie? 1 over 1 plus u squared. 1 over 1 plus u squared. And if we square the sine squared of x over 2, what do we get? Square sine of x over 2, what do we get? U squared over 1 plus u squared over 1 plus u squared. Very nice. Okay, now, common denominators, they're there. Now just Subtract the fractions. What do we get, Charlie, on top? 1 minus u squared. 1 u squared. Very nice. And the bottom is 1 plus u squared. Very nice, Charlie. Okay. Now, let's go back to our problem here. Remember, sine x is going to get replaced with what? 2u over 1 plus u squared. That's right. Cosine of x is going to get replaced with 1 minus u squared over 1 plus u squared. So we now know how to replace our sine x in terms of u, also cosine x in terms of u, but there's one last thing we got to replace, Charlie. What is it? Dx. The dx, that's right. Don't forget, you got to replace the dx too. And so let's go back to our original substitution, u equals tangent of x over 2. Now, Charlie, if u equals tangent of x over 2, x over 2 is equal to what? Remember, here's a hint. It involves an inverse trig function. Inverse tangent of u. Inverse tangent of u. Very nice. That's true. And now what we're going to do is differentiate both sides of our equation with respect to x. So, Charlie, what's the derivative of x over 2 with respect to x? 1/2. 1/2. That's right. Now, we're going to differentiate the right-hand side with respect to x. Now, this is implicit differentiation. So what do we get, Charlie? Derivative of inverse tangent of u over, with respect to x is what? 1 over 1 plus u squared. 1 over 1 plus u squared du dx. That's right. And remember, this implies that 1/2 dx is equal to 1 over 1 plus u squared du. There we go. Okay, we're almost done. We've got to solve for dx. Don't forget. So we're going to multiply both sides by 2. And what do we get for dx, Charlie? 2 over 1 plus u squared. 2 over 1 plus u squared du. Very nice. Okay, now we know how to replace sine of x, cosine of x, and dx. So here we go. We're finally going to get started on this integral. This was just the warm-up, Charlie. This is a long problem. That's right, yeah. This will be a long problem. Now, remember, you don't have to finish the problem now. You can always come back and do it next semester. That's right. Okay, let's get back to work, Charlie. Break's over. Here we go. 1 over 4 sine x subtract 3 cosine x, Charlie. Okay. Now, remember, this is all based on the substitution u equals tangent of x over 2, which implies that dx is 2 over 1 plus u squared du. Also, sine x is going to get replaced with 2u over 1 plus u squared, and cosine x is 1 minus u squared over 1 plus u squared. Okay, so here we go. Let's put everything into our integral now. So here we are. We have an integral of 1 over 4 times what, Charlie? 2u over 1 plus u squared. That's right, 2u over 1 plus u squared. Okay, subtract 3. Now replace the cosine x. What do we put in there? 1 minus u squared over 1 plus u squared. 1 minus u squared over 1 plus u squared. Very nice. Now we got one more thing to replace. What is it, Charlie? Dx. Dx, that's right. Okay, and what does dx equal to? 2 over 1 plus u squared. 2 over 1 plus u squared du. Whew. Okay, now, it's algebra. You've got to be very careful here. Now, pay attention to this very closely, Charlie. Now, notice, in these brackets here, we have this difference of these two fractions here. Now, those denominators are both 1 plus u squared, but they will be canceled by the 1 plus u squared that's showing up in the dx, right? They'll be canceled out. It's a distributive property there. And so what's left on top, Charlie? 2. 2. And the bottom, what do we have, Charlie? 4 times 2u. That's right. Subtract what? 3 times 1 minus u squared. 3 times 1 minus u squared. Very nice, Charlie. Okay. And don't forget, it's a du. Now, you got to clean up that denominator a little bit. So what do we get in the denominator, Charlie? 8u minus 3 plus 3u squared. Very nice. Yeah. Don't forget, it's a du there. Okay, and now we have this quadratic in our denominator. Let's put it in, let's put the exponents in descending order. So we get 3u squared plus 8u subtract 3, and don't forget du. Okay, now we have our denominator expressed as a quadratic. So we got two choices here, Charlie. We can take this denominator here, complete the square, and that would take us into trig substitution. Do you want to do that, Charlie? No. I didn't think so. Okay. What we're hoping is that denominator is factorable, because if it is factorable, Charlie, we can factor it and go into what procedure? Partial fractions. That's right, partial fraction decomposition. Now, here comes the question. Is that quadratic factorable?